Hi everyone, my name is Abhiraj Garikapati. Welcome to my YouTube channel Amazing Abhi. IOCP is the checkpoint between a written IOCDS map and the machine using that map. Think of it like a building inspector. A construction plan may look complete, but before workers use it, somebody must check whether the plan follows the required rules. IOCP does that job for the IOCDS. It reads the configuration text, checks the structure, and either accepts it or stops the process with errors. In this topic, we will learn what IOCP can protect us from, and just as importantly, what it cannot protect us from. Imagine a city building a new road network from a written plan. If a street name is missing, if an intersection is drawn in the wrong order, or if a road is connected to a type of bridge that cannot support it, the plan should be rejected before construction starts. IOCP plays that kind of role. It does not build the hardware, and it does not decide business intent. It checks whether the IOCDS structure is valid enough to be used. That makes IOCP one of the first safety gates in IO configuration work. The easiest way to remember IOCP is to compare it to a compiler. A compiler does not ask whether the program solves the right business problem. It checks whether the code follows the language rules and whether the pieces fit together structurally. IOCP works in a similar way for an IOCDS. It reads the text, checks the required structure, and produces either a valid assembly or errors that must be corrected. This comparison is useful because it also reminds us about the limitation. A program can compile and still be logically wrong. In the same way, an IOCDS can assemble and still point to the wrong real-world destination. IOCP can appear in two important moments. First, it runs during machine load, when the selected IOCDS is being brought into use. If the structure is invalid, the load stops. Second, IOCP can be run as a standalone test before the change reaches production. That second use is the safer habit. It is like checking a bridge design before the bridge is open to traffic. You want to discover missing columns, wrong keywords, or broken references while the work is still in a test space, not while the whole environment is waiting for startup to finish. Before we move ahead, please take a second to like on this video. A like tells me that you enjoyed this topic. Your support helps Amazing Abhi grow naturally. This flow shows the basic life of an IOCDS through IOCP. The source file goes in. IOCP reads the statements and checks rules such as syntax, order, references, and compatible types. If something is wrong, the output is an error listing that tells the engineer what must be repaired. If the file passes, the structure is accepted, but there is still another gate after that. People still need to confirm that the accepted structure describes the real hardware and the intended destination. IOCP can approve the grammar of the map, but people must verify that the map leads to the right place. The first kind of protection IOCP gives is syntax checking. Think about signing a legal contract. If a sentence is incomplete, if a required field is blank, or if the wording breaks the required format, the document cannot be accepted. IOCP treats that IOCDS with that same strict attitude. It checks things like column positions, continuation characters, statement names, keywords, and punctuation. These may look like small details, but in this environment, small text mistakes can prevent the configuration from being assembled at all. IOCP also checks whether the configuration is built in the right order. A good everyday comparison is assembling furniture. The instructions usually tell you to build the frame before attaching the shelves, and to attach the shelves before adding the doors. If you jump ahead, later parts have nothing stable to connect to. The IOCDS has the same idea. Higher level definitions must exist before lower level definitions can depend on them. IOCP catches ordering issues and references to things that are not defined where they need to be. Before we move ahead, please take a second to share on this video. Sharing helps this video reach friends who may also enjoy anime, gaming, travel, cricket, chess, career basics, or personal stories. Your support helps Amazing Abhi grow naturally. A second useful comparison is plug compatibility. You may have a real device and a real cable, but if the connector does not match the socket, they do not belong together. IOCP performs this kind of structural compatibility checking. It can catch situations where a channel path type, a control unit type, and a device type do not form a valid chain. It can also check selected limits based on what the hardware model supports. These checks are valuable because they prevent impossible combinations from becoming active definitions. This is the most important warning in the topic. IOCP checks structure, not intent. Imagine a delivery address that is typed in a perfect format, but belongs to the wrong house. The delivery system may accept it because the address looks valid, but the package still goes to the wrong place. IOCP has the same limitation. It cannot know whether a link address truly reaches the storage system you intended, whether a switch port is connected as planned, or whether a valid logical value points to the correct real destination. That is why IOCP is necessary, but not sufficient. Here is the dangerous situation in story form. An engineer writes a configuration. The columns are correct, the statement order is correct, and the type chain is compatible. IOCP passes the file because structurally it is valid, but suppose one address leads to the wrong switch port or one control unit address represents the wrong logical control unit. The system does not understand the engineer's intention. It follows the accepted map. That is why a clean IOCP result should feel reassuring, but never final. It means the plan can be read. It does not prove the plan is right. Before we move ahead, please take a second to like on this video. A like tells me that you enjoyed this topic. Your support helps Amazing API grow naturally. A safer process treats IOCP as the first gate in a larger review chain. The author checks whether the configuration expresses the intended change. IOCP checks whether the structure follows the rules. Storage specialists confirm that the volume, control unit, and device details match reality. Switch specialists confirm that ports, paths, and routes are what the configuration assumes. This teamwork matters because each group sees a different part of the truth. IOCP can validate the written structure, but real safety comes from combining that structural check with human review of the physical environment. A useful way to avoid overtrusting IOCP is to divide the questions into two groups. IOCP is excellent at rule-based questions. Is the syntax valid? Is the order correct? Are the references defined? And are the types compatible? People must answer intent-based questions. Is this actually the destination we wanted? Is the cable connected to the expected port? Does the switch route lead to the right storage? And is the change safe for production? When both sides are used together, the configuration process becomes much stronger. For a beginner, this three-part model is the easiest way to remember the topic. First, IOCP checks grammar. The text must follow strict formatting and syntax rules. Second, IOCP checks structure. The defined components must appear in a valid order and fit together in allowed combinations. Third, people check intent. Humans must confirm that the valid structure represents the desired real-world connection. If you remember this model, you will know exactly where IOCP helps and where human validation must take over. The main lesson is simple. IOCP is the compiler and structural validator for the IOCDS. It is essential because it catches many mistakes before a configuration becomes active. It can catch syntax problems, ordering problems, undefined references, incompatible type chains, and selected limit violations. But it cannot read human intent. It cannot know whether a valid address is the intended address or whether the physical environment matches the written map. So the safest approach is to run IOCP early, fix all assembly errors, and then combine that result with careful review from the teams who understand storage, switches, and production risk. The next topic introduces HCD, which provides a guided management layer on top of this configuration ecosystem. If you enjoyed this video, please hit the like button and subscribe to Amazing API. Subscribing makes sure you do not miss the next video, and it gives me motivation to keep improving the quality of every upload. Thank you for being here, and I will see you in the next one.